So let's do the y2 integral. So if I do the y2 integral, what would be the integrand? So let's dy2 e to the power I, and then it'll be y2 minus y1 squared, then plus I, y3 minus y2 squared, right? So these are the only terms that are going to be from this sum. Only these two terms will have y2, right? So then what we do is that we take the argument, well, except the I, let's just simplify that, y2 minus y1 whole squared plus y3 minus y2 whole squared. And then we expand this. And when we expand this, and it turns out to be 2y2 squared minus y2 times 2y1 plus 2y3 plus y1 squared plus y3 squared. So what I'm doing here is that I'm writing it in the form where this is y squared, this is linear in y, and this has no y in it, so that I can use this formula, right? The factor that the term that doesn't have y in it, it just goes on for the ride for free. So as a result, what we get is d of y2 e to the power I, y2 minus y1 squared plus I, y3 minus y1 squared is going to be pi divided by minus 2I, because if you look at this thing, the coefficient of y2 is going to be I times 2 is going to be equal to minus a, right? And then we have this term, and this term is going to be e to the power I y1 squared plus y3 squared. But doing the Gaussian integral will generate another term, because we did a completion of the square, and that will be the term which has I minus I y1 plus y3 whole squared divided by 2. Okay. So okay, let me just show you how this works. Because let me just take this formula, copy it, bring it down here where we can see, and paste it here. Okay, and then we can see that our A is going to be minus A is I times 2, right? And B is going to be minus I 2y2 plus 2y3. Okay, and so here we are going to get, so this term was already there because this is this term. But for this term, what we have is b squared by 4a. So b squared is going to give me a minus sign here. And then we are going to get the square of this. But then we are going to factor out 4 there. But that 4 will cancel with the 4 coming from the denominator. But a has itself in it minus 2i. So we are dividing by minus 2i. And when I take the I upstairs, we get another minus sign, right? So I think, I think this is correct. So I'm just explaining why there's a factor of half here, okay? Is that clear? I mean, you have to do these things by yourself, right? Otherwise, these are just like, it's like addition. You have to do addition by yourself. Okay, so now we have done is that we have done the y1 integral. So Ekman, what we can do is that we can simplify this term. So what do is that we expand this, and then we have, by the way, we can take the I upstairs in the square root, so the minus sign goes away. And then we have e to the power, say, minus I by 2 from here. And then we expand, so we get y1 squared plus y3 squared plus 2, y1, y3. And then this guys, but these guys will have a factor of 2 now. And because of the minus sign, there's a minus here. So it'll be 2 y1 squared minus 2 y3 squared. So we see that the signs in front of these guys will switch as a result. I pi by 2 square root, and we'll get e to the power plus I y1 minus y3 squared by 2. Okay, so this is the result of doing the first integral. Any questions?
No, sir.
Okay, so now what do? We do the y3 integral. So if I look at the y3 integral, there's a there's already this term, this factor, which is pi I by 2 square root dy3, and then there is e to the power I y4 minus y3 squared. So this is coming from this sum, right? It's coming from this sum. It's coming from this thing. So this guy is the y3, but then we also get a y3 term from the previous integral. And what is interesting here, what is important here is that there's a factor of half here. There is no factor of half here. So the integral will be slightly different from the previous time. So we get e to the power I y1 by y3 squared by 2. And if I now do the same sort of simplification, that is, expand this and combine with this, and then we have to write everything in terms of, there will be a term which will be quadratic in y3. So it'll be a y3 square, a y3 squared plus b y3 plus c, right? We have to express this exponent in this form. So if I do this, then, because I'm doing Gaussian integral, so I have to bring it in that form. So we have d of y3 e to the power. Now we get the coefficient is no longer I by 2, it's 3 halves by I 3 halves y3 squared, and then minus I y3 2 y4, because there's a square coming from here, from the y4, and then minus y1.
Sir, if n equals to 3, then y3 minus y2 shouldn't be it instead of y4 minus y3?
Sorry, can you repeat that?
N equals to 3, right?
N is, you mean small n?
Yeah, small n.
And what was your question? If small n is 3?
Shouldn't it be like y3 minus y2 instead of y4 minus y3?
No, because n is, we are doing the we are doing the y3 integral, But for y3 integral, what we have to take here is, uh, you know, uh, there will be a term where this is 3. In that term, this will be 4. So we have to take that term into account, right?
Oh, I see. I see. Yeah. Okay. That
Yeah.
makes sense.
Okay.